Welcome to part 2 of this lesson. So in the first part, we talked about translating a single point. In this lesson, we're going to now talk about translating an entire graph. And the first thing that you'll see here are very detailed instructions on how to do this process. Now, the notation for this process can seem a little complicated, and I'm not quite sure how useful it will be for you if I just kind of read through these instructions to you. I think it would be far better for me to actually do an example, and then later on you can refer to these instructions. But I really think that this right here, this section right here of the notes, is going to be extremely valuable to you because you might get lost in these steps. So it's just some place where you can refer to. I think will be useful. Okay. But I want to go through an example. I think people learn best by going through an example. So let's look at this one right here. So remember, what we're doing here is we're translating an entire graph, not just a single point, as we were doing in the last video. Okay, it says, if y equals x squared is transformed 2 units in the positive x direction and 4 units in the positive y direction, find the rule of the transformed function. Now, just because we're just starting here, I think it's going to be useful for us to just visualize what's going on here. So what it's saying is we're starting with y equals x squared, and that's this red graph right here. That's what we're starting with, y equals x squared. And then we're applying these translations to the entire graph. And we're arriving at this new graph right here, this blue one. And what the question is asking us to do is find the rule for this blue one. So we don't know it yet, but that's what we're trying to do. So we're not just translating a single point, we're translating an entire graph, and we need to find the rule of the transformed function. Now, you're probably thinking to yourself, I know a really easy way of answering this based on our knowledge from our gallery of graph sections and previous things you've done in math so far. Let me just quickly partition this off. You might want to do the same. You're thinking, I know a really easy way to do this. Let's just write A. There's going to be A way to do it, and there's going to be B way to do it. The first way to do it is just to do it by what I would call inspection. And inspection really just means, hey, I'm starting with y equals x squared. I know that I'm going 2 units in the positive x direction, so that's 2 to the right. And I'm going 4 units in the positive y direction, so that's 4 up. Based on my knowledge of how these graphs work, I know that if I'm going 2 right, it's going to look like this, y equals x minus 2 squared. And if I'm going 4 up, it's going to be plus 4. And that right there is the answer. We have gotten the answer by inspection. And that's really just using the knowledge that we already have. But here's the thing, we're going to have to know the other way of doing it too, the more complicated way, the way that's very heavy on notation, this way right here. So this is now the way we're going to go through it. And these instructions will be here if you ever get lost. So we're now going to go through the more rigorous way of going about this. And it may seem pointless in its complexity, but it's really going to be useful when we get to more complicated questions, when we've got dilations and reflections and translations all happening at once. So you're just going to have to believe me that this is a useful technique. Okay, so how are we going to approach this? The first thing I want you to notice is that when we're translating an entire graph, what we're doing is we're just moving lots of different points, aren't we? For instance, we're moving this point over here, we're moving this point over here, we're moving this point over here. So in the previous video, we talked about moving a single point. Well, moving an entire graph isn't that different because an entire graph is just made up of lots of single points. So the first thing that we're going to do, step 1 of this process, is we're going to say, hey, we're starting with a point, and this xy kind of represents every point on this graph. And we're going to our new point, our newly transformed point, which is x dash y dash. And this x dash y dash represents every new point on our graph. Now, let's rewrite this again. xy is going to our new point. Whoops, let me try that again. What can we say about what x dash is going to be? Well, every point on my old graph is going to go 2 units in the positive x direction. So that means x dash is x plus 2. And would you agree with me that every point here is going 2 units in the positive x direction? Of course. And what about y dash? Well, my y dash is going to be y plus 4 because it's 4 units in the positive y direction. And yet again, every point on my old graph is going to go 4 units up. So this is a true statement. Okay, that's step 1. Step 2. Step 2, we're going to form equations. So what we're going to do is this. We're going to say, hey, x dash is equal to x plus 2, that we know. And we also know that y dash is equal to y plus 4. So we're going to create an equation on that. We know that my new x position is x plus 2, and we call that x dash. And we know that our new y position, y plus 4, is y dash. So that's what we know. And that's our second step. Pretty easy, isn't it? What is our third step? We're now going to solve for x and y. So that means I'm going to minus 2 to both sides here, and I might even write this in just so you know what's going on. I'm solving for x. So I'm going to minus 2, and then over here I'm going to minus 4, minus 4. So that's going to leave me with x is equal to x dash minus 2, and over here I'm going to get y is equal to y dash minus 4. Now, these things right here are extremely important. These are going to be very important, so let's just highlight those. Okay, we're now going to move on to step number 4. Step number 4 is going to be all about substitution, so sub. We're going to start with our original graph, y equals x squared. And what we're going to do now is we're going to put our new y value, so this right here, we're going to put that into the y spot, and we're going to put our x value, x dash minus 2, we're going to put that into the x spot. So we're subbing in these points, or x equals this and y equals that, into our original graph. Okay, so we're subbing these in to this. So into the y spot, I'm going to get y dash minus 4. And into my x spot, I'm going to be putting in x dash minus 2 squared. Step 5. We are going to solve for y and drop the dashes. Ooh, dashes. So that means I'm going to end up with y dash equals x dash minus 2 squared plus 4, and then drop the dashes. So that means I no longer need that dash here, I no longer need that dash there. This right here is my answer, so let's give that a highlight. And as you can see, that right here, y equals x minus 2 squared plus 4, is what we originally got. This process is important. I know it seems complicated. I know it seems pointless because we can get the answer so quickly, but trust me, this is going to be very useful to us later on when the questions are really more complicated. And it's good that we can practice now on these easy questions, and we're going to practice a lot more. These instructions, if you ever forget, can be found here. So do not stress if you ever forget them. All right, so I think I'm going to stop this video here, and then in the next video, I'll go through some more examples and yeah, just to really help you out. So hopefully going through this process has made sense, and in the next video, so part 3, I'll go through some more questions just to really solidify what we've learned here. Okay, hopefully you found this useful.